Hi everyone. Today we are going to learn about structural isomerism. See what is structural isomerism and what are the types of structural isomerism. Okay, let us start our video. See, structural isomerism is the type of isomerism. What is isomerism? Already we discussed that link. I'll be give in my description box. If you not see, just see that video also. So isomerism is nothing but any two compounds which has the same molecular formula but differ in their physical and chemical properties. Such are said to be isomers to each other, and that phenomenon is called isomerism. In that isomerism, we have two types, structural isomerism and stereotype. That stereoisomerism we'll discuss later. Today, what is structural isomerism? This structural isomerism is due to the difference in which the attachment of the atoms to the molecule or any given compound, any atom or group of atoms are attaching to the given molecule. Maybe they can attach in the different structural forms. So how we can define the structural isomerism? The structural isomerism, these are the compounds. The structural isomers are the compounds having same molecular formula, having same molecular formula but different structural formula, but different in structural formula. In structural formula. So this is called structural isomerism, and this phenomenon is called structural isomerism. They'll have the same molecular formula but they'll be arranged in different structures. Okay, see, these are the types of the structural isomerism: chain isomerism, position isomerism, ring chain isomerism, functional isomerism, metamerism, and tautomerism. In today's video, we are going to discuss about chain isomerism and position isomerism. Okay, let's start. What is chain isomerism? What is chain isomerism? See, chain isomerism is a type of isomerism. This one shows due to the difference in the arrangement of carbon atoms to a chain, to the constituting the chain. See, suppose we are taking one molecule. I am taking C4H10. C4H10. It is butane, isn't it? The name of this compound is butane. So, how we are arranging? So, carbon chain, 4 carbons we have. I have taken 4 carbons in a straight chain. So, here it is CH3, CH2, CH2 and CH3. This is butane. We can write the butane like this, and we can write even like this also. C, and like this. Here it is CH3, CH3, CH3 and it is CH2. This is also C4H10. This one we are calling as branched. Means this is a carbon chain but it has a branch. Its common name is isobutane. Isobutane is its common name. Its common name is butane. Its common name is butane. Its common name is isobutane. But its IUPAC name we can write 1, 2, 3. Second carbon having methyl as a branch. So we can write it is as 2-methyl. 3 carbons no prop. So 2-methyl propane. This one simply we can write as a butane. So these are the same molecular formula, C4H10 butane, same molecular formula, but the arrangement of the carbon chain is different. Here I have taken a straight chain. Here I have taken a branched chain. Here we have taken branched chain. So these two are said to be chain isomers to each other. So now how can we define chain isomers? Straight or branched chain of carbon atoms. And one more thing, this chain isomerism is also known as nuclear or skeletal isomerism. Nuclear isomerism or skeletal isomerism also we can call chain isomerism as nuclear isomerism or skeletal isomerism. So now how can we differ this one? The isomers showing chain isomers belongs to the same compound. Different chain, straight chain and the branched chain they are showing, right? So this is about the chain isomerism. Now this we have taken example for butane. So next example I am taking is pentane. Pentane molecular formula is C5H12. How many chain isomers does it have? Means this C5H12, how many chain isomers like we can arrange? How many isomers we can write actually for this? See, C5H12, we can arrange a straight chain. This is one chain, 5 carbons. And we can arrange even like a branching. Yeah, CH3 we can keep here. This has one branch and we can write with the 2 branches. If you complete these compounds, it is CH3. How I am writing the hydrogens according to the carbon's valency. Carbon should show 4 bonds, right? So this has 4 CH2, CH2, and here it can write CH2 and it is CH3. It is a straight chain. The name of this compound in common name it is called N-pentane. Common name is N-pentane. IUPAC name is just pentane like we can take. And here it has the branches. See CH3 and even it has CH2. 1, 2, 3. Already this carbon has 3 bonds. So I am writing only one hydrogen. Now write the numbering 1, 2, 3, 4. So see it has the numbering 1, 2, 3, 4. Second carbon having the branch of methyl group. So this one we can write as iso. How many carbons are there? 1, 2, 3, 4, 5. So total 5 carbons. This one we can write as isopentane is its common name. And its IUPAC name is second carbon having methyl group. So 2-methyl butane. 2-methyl butane. And another one, this has 2 branches. I am giving this one CH3. It has only one bonding CH3. It has CH3. This carbon has 1, 2, 3, 4. 4. So how to give the numbering for this one? See, the numbering is 1, 2, 3. Okay. So second carbon has 2 branches. How can we write this one? Actually in common name, this one we are calling as Neopentane. This is called Neopentane is its common name. Come to the IUPAC name, second carbon having 2 methyl groups. So we have to write 2, 2. 2 times methyl has come. So 2, 2 dimethyl propane. 2, 2 dimethyl propane because it has 3 carbons. So 2, 2 dimethyl propane. These are the examples for chain isomers. Chain isomers means all the molecular formula is same, but the difference in their structural arrangement means to the carbon chain how the compounds or molecule group of atoms or atoms attached to the given chain. So now we can say how many chain isomers that C5H12 has. 3 isomers. C4H8 that C4H10. Butane has how many chain isomers? It has 2 chain isomers like we can say. So these are the examples for chain isomerism. Okay, pentane I have taken and butane I have taken and I have shown. So here we are going to do the question on pair of isomers. See, he is asking the question, select the pair of chain isomers from the given questions. So see, in the given, they have given some questions. From that we have to, so select the pair of chain isomers. Here they have given some of the questions. We have to choose which are the chain isomers to each other. Okay, comes to the first question. So this is called bond line structures, like we can say. So what here, one carbon, carbon, carbon and carbon. That is we represent the molecule with a bond line structures. This is one of the representation of the molecular structures. See here, 1, 2, 3, 4, 5. And this one, to understand, I'll write the structure. See first, CH3, 1 carbon, 2 carbon, 3 carbon and here 1 carbon. And this carbon has a bond. And the remaining are, we have to write the hydrogen. See here, this carbon has 1, 2, 3. Already it has 3 bonds. So I have to write 1 hydrogen here. Comes to here, 1, 2, 3, 4. This carbon has 4 bonds. So no hydrogens. Comes to this carbon has only 1 bond. So we should write 3 hydrogens. Come to this carbon, even this carbon is attached with only 1 carbon. So remaining 3 hydrogens. So this is the structure, actual structure. See its molecular formula, 1, 2, 3, 4, 5. Total 5 carbons. And count the hydrogens, 3 hydrogens, 4, 5, 6, 7, 8, 9, 10. So it has C5H10 molecular formula. And comes to here, let's check the hydrogens here. So I'll write 1 carbon, 2, 3, 4, 5. Okay, second one has 5 carbons. Come to here, 1, 2, 3, 4, 5, 6, 7, 8. It has 8 carbons. Even comes to here, 1, 2, 3, 4, 5, 6. This is 7th carbon. It is 8th carbon. 8 carbons. We need only 5 carbons. Check here. 1, 2, 3, 4, 5. 5 carbons. 1, 2, 3, 4. And this is another carbon. 5 carbons. But we don't have oxygens. These two are not the chain isomers, because in this they have the oxygens. But in our molecular formula, we don't have a oxygen here. So only carbons and hydrogens. So we have to choose the structures which has only carbons and hydrogens. These 4 structures only having carbons and hydrogens. Come to these two. They have 8 hydrogens. 8 carbons. Sorry. These two compounds having 8 carbons. But second one has the only 5 carbons. So for the first one, second one will be the pair. Second one will be the pair. These two are the pair of chain isomers to each other. If you want, I'll elaborate the structure of this compound also. See here, and here it is the first carbon, 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 and here carbon. Between third and fourth we have a double bond. Remaining one, write the hydrogens. This carbon has 1, 2 hydrogen, 1, 2, 3. So it has 1 hydrogen, and 1, 2, 3. It has 1 hydrogen, and even this carbon having only 1 bond. So it should have 3 hydrogens over here. So total number 5 carbons, 3 to 5, 6, 7 plus 3, 10. C5H10. So first structure and second structure, 1 and 2, both are chain isomers to each other, like we can say. Come to the third and fourth. This compound has 8 carbons. This compound has 8 carbons. Obviously, they'll both have the same amount of hydrogen. So these two are chain isomers to each other. And comes to here, these also, because this has 5 carbons. This has 5 carbons. It has 2 oxygens. Here 2 oxygens, and the hydrogens will be same. Okay, like this we have to check the how they will be chain isomers to each other. Same molecular formula but differ in their structural arrangement. It is a branched chain. It is a straight chain. Okay guys, This chain isomerism is also known as nuclear isomerism or skeletal isomerism. Okay guys, thank you. Actually I want to explain position isomerism also, but the video is lengthy now, also 15 minutes video, so I'll do in my next video, and I'll try to shorten the video timing, means just a 5 minutes or 6 minutes video, like that, maximum 10 minutes video to do. I'll please do follow and subscribe to my channel, and do see the all the videos. Okay guys, thank you so much.